Welcome everyone to the next specialist forum. We'll go ahead and get started.
Yep.
This forum is to discuss Forane's line of low GWP refrigerants for heat pumps. I am Chris Crosby with Arkema. We are at booth 408 in Hall 9. Please come by, and with any questions you have on today's presentation or to talk to us any further about any of our products or their applications. So in today's presentation, as I mentioned, we will be talking about our line of low GWP refrigerants, starting with Forane 32, which is used currently in heat pumps across the world, and then moving into our less than 150 GWP refrigerants, including our Forane 516A refrigerant, which is used in air-to-water heat pump applications, heat pump water heaters and chillers, Forane 457A, and we will discuss that in the residential light commercial heat pump application. And then finally, last but not least, we'll move into Forane 1233ZD in high temperature heat pumps. So starting with Forane 32. Forane 32 is a lower GWP refrigerant with a GWP of 675. It is an A2L product, so it is mildly flammable, and it has zero ozone depletion, and it is a non-PFAS material. This is currently being utilized in heat pumps across the globe and has been for many years. Is just beginning to be adopted in the United States in heat pumps, along with some other refrigerants. Some of the relevant properties related to R32 in relation to R410A, it does have a enhanced capacity and efficiency with a 10% higher capacity and up to 5% higher efficiency, while reducing the charge size up to 20% versus 410A. Because that material is 50% of the blend of 410A, it does have similar stability and compatibility to 410A, while it also has a cost that tends to be slightly lower than 410A. And if you would like additional information about this material, we will have another forum on Thursday to discuss Forane 32 and R454B in more detail. So please attend that if you have more interest. Moving on to the less than 150 GWP refrigerants, we will start out with Forane 516A. This refrigerant blend is a 3-component blend comprised of 1234YF at 77.5%, 14% 152A, and 8.5% 134A. This gives it a GWP of 142. It is an azeotropic blend, so amongst less than 150 GWP blends, that's something that is fairly uncommon. So it does have zero glide and behaves much like a single component refrigerant, which is very advantageous in many situations. It is an A2L, as are most refrigerants under 150 GWP, so it is mildly flammable. It is the closest match to 134A properties amongst less than 150 GWP refrigerants. So that allows you to have very close matching thermodynamic properties to 134A, which mean very few design changes are required to adopt this 142 GWP refrigerant into those applications and get a 90% GWP reduction in those applications. Right. So moving into some of the testing that has been done with R516A in heat pumps. The first application is a low ambient air-to-water heat pump. This testing was done through one of our industry partners who tested this in a system, air-to-water heat pump system, which was utilizing an oil-free centrifugal 134A compressor. And it was drop-in tested in the system to compare the performance of R516A to R134A. As you can see on the chart on the left, the 516A has very similar capacity, COP, and compressor speed when compared to 134A, both in cooling and heating mode. Slightly closer performance in heating mode than cooling, but both are very similar to 134A. On the right-hand side, you can see the compressor discharge temperature as a comparison between R516A and R134A. You do get a significantly lower discharge temperature with 516A versus 134A, which allows potential broader operation map when compared to 134A. So it was identified by our partner as an ideal candidate for air-to-water heat pumps. The next application for 516A we wanted to discuss is residential heat pump water heaters. This was, again, tested by one of our industry partners, drop-in tested in a residential integrated heat pump water heater that was designed for 134A. And that testing showed that you could use less refrigerant in the same system. So you had a 12.5% reduction in the refrigerant charge size with R516A versus R134A. It was also more efficient. So the uniform energy factor had a 14.5% increase with 516A versus R134A. And then you were also able to maintain the first hour rating of that heat pump water heater when compared to 134A. So you had equivalent performance in that regard. So again, in this application, R516A was identified as an ideal replacement for 134A in heat pump water heaters, allowing you to have a lower refrigerant charge, higher efficiency, and equivalent first hour rating.
Right.
The final application I wanted to discuss on 516A is in chillers. This evaluation was done on a 370 kilowatt air-cooled 134A screw chiller. This, again, was a drop-in test, and this was done as part of an ASHRAE paper that was presented several years ago. But the performance of 516A was on par with 134A and looked very similar in regards to capacity and energy efficiency. So this was performed in the cooling mode. However, we expect that this would also be similar performance that we would see in a heat pump chiller as well. And we hopefully will have some data to present on that in the future. Moving on to the next less than 150 GWP refrigerant, it would be Forane 457A. This again is a 3-component blend comprised of 70% 1234YF, 18% R32, and 12% R152A. It is, again, a less than 150 GWP. It has a GWP of 139. It is an A2L, so it is mildly flammable. It is SNAP listed in all of its applications in the U.S., and it has a favorable critical temperature for heat pumps compared to some of the other less than 150 GWP refrigerants that you see that are comparable. In addition, it has a competitive capacity and efficiency when compared to those refrigerants. And so you are able to adopt a less than 150 GWP refrigerant into applications that maybe previously used R410A, R32, or R454B. The application in heat pumps we wanted to discuss was residential heat pumps. This was chosen by Oak Ridge National Laboratories in the U.S. to be tested as part of their residential split heat pump project that used less than 150 GWP refrigerant. This was a DOE-funded project that Oak Ridge has been working on for the last few years. And the goal of the project was to develop a low-cost direct expansion heat pump system using a long-term refrigerant with GWP less than 150 that could suit mainstream building and equipment structures. The two goals that they had, the two performance goals that they had, were to achieve a seasonal cooling performance of greater than 16, so a SEER of greater than 16, and to achieve a seasonal heating performance, HSPF, of greater than 9. So they selected R457A as the refrigerant of choice to use for this application because of the properties of the refrigerant, the higher critical temperature as compared to some of the other alternatives at less than 150 GWP. And in the testing that was performed by Oak Ridge, they were able to exceed the HSPF goal. So they hit a HSPF of 10.1 versus the goal of 9.0. And they were also able to meet the SEER goal target within the allowed tolerance. So the SEER that was achieved was 15.7, which is within the tolerance of the goal of 16.0. They also were able to meet the rated capacity at 3.2 tons, and their goal was a 3-ton system. In this test system, the compressor isentropic efficiency was also very favorable. So it hit 70%, which was very comparable to the 410A scroll compressor that was used in the same application. So very strong results of 457A in Oak Ridge testing in residential heat pumps. The final application that we wanted to discuss today was Forane 1233ZD and heat transfer applications. This is an exciting product for Arkema. It is a extremely low GWP product with a GWP of 1. It is a single molecule refrigerant, and it is a A1 non-flammable, low toxicity product. We are in the process of building a plant in our Calvert City, Kentucky facility in the United States. This is a over $60 million investment for Arkema in the Calvert City, Kentucky facility, and we will be starting production of this product in late 2024. So the heat pump application that we wanted to discuss for 1233ZD is high temperature heat pumps. This product has an ideal properties for the high temperature heat pump application with a 18 degrees Celsius boiling point and a 166 degrees C critical temperature. So it fits into the range of many high temperature heat pumps and pushes the heat source and the heat sink temperatures to higher levels than some of the other alternative refrigerants that are sometimes used in this high temperature heat pump application. It can utilize waste heat from many sources, and it's used in many different applications for high temperature heat pumps, including pharmaceuticals, paper mills, industrial dryers and ovens, low temperature steam, and food production. So this is a newer application for this product, but one that we're very excited about and very excited to see this product continue to be adopted into these applications. So wrapping things up in conclusion, the products that we've talked about today, first was Forane 32, which is the current refrigerant for many heat pumps across the globe, used in millions of units across the world. And then moving into the less than 150 GWP refrigerants, we have Forane 516A, which can be used in air-to-water heat pumps, heat pump water heaters and chillers. Forane 457A, which is a less than 150 GWP refrigerant for residential and light commercial heat pumps. And finally, Forane 1233ZD, which is a GWP of 1 refrigerant for high temperature heat pumps and waste heat recovery units. Again, my name is Chris Crosby. If you have any questions, feel free to see me after at the conclusion of this, or come by our booth in Hall 9, booth 408, if you have any questions, or feel free to email me at chris.crosby@arkema.com. So thanks for your attendance today, and feel free to reach out with any questions. Thanks a lot.